Good afternoon, Psychology 241. How's everybody doing today? It's good to see you. Check in if you would. Send a hello on the chat bar. Let me know you're listening. How's it going? Melanie G, Michaela, Ninja Oxendine. It's good to see everybody. Fantastic. Michaela says she had a nice weekend. Ali, good to see you, Ali. Nice to see you. Fantastic, everybody checking in. Hope y'all are ready for week 4. We are coming up to the midterm exam, which will be due this coming Monday. I haven't done it yet, but I'm going to make a meeting, Microsoft Teams meeting for Sunday night at 9 p.m. for our review session. You can do the exam before then, but I won't be doing the review session until Sunday night. The exam is due on Monday night for anybody who wants to wait till Monday to do it. Cool. We are a quarter of the way into this semester. I don't know if you're as excited as I am. How are your classes going? I hope well. Fantastic. Oh, and hello, Dee. I just saw your message. Good afternoon to you as well. It's great to see everybody in class. Looks like we have a pretty good crowd. Let's go ahead and get started. If anybody has any... Oh, no. Melanie, why is your class going horrible? That frowny face, what's up with that? Your classes should be going wonderful. Yeah, I'll go ahead and type you in a message if you want. I'm going to go ahead and get started. Today we're talking about physical development in infancy. We're going to talk about this week we're going to talk about the expectations for growth during the first 2 years. We're going to be talking about the sleep patterns during the first 2 years of life. We're going to talk about the neurological changes as an infant's brain matures. We're going to talk about what is meant by the cephalocaudal and proximodistal principles of development. We're going to talk about the move from reflexes to voluntary motor control, and we're going to talk about why doctors care about milestones. Xiaoshun is also in class too. She's checking in on my mobile phone, so I'd like to send a shout out to Miss Huang. It's good to see you. Andre, fantastic. Glad to see you. It is Blooming and Pruning Day. Wow. Talk about a little bit of foreshadowing from Melanie G. Fantastic. Okay, so let's go ahead and orient ourselves. This is a chart from chapter 1. And today we're actually finally starting sort of the routine through the child development program. And we're on chapter 4, which is physical development in infancy. Oh, we got Erica Schultz also checking in on the cell phone as well. Good day, Eric. I hope everything's going well at the doctor's office where you're at. Make sure you keep your mask on, okay? So, if you remember, I told you that we could organize human development by looking at these 8 ages of life: prenatal development, infancy, early adulthood, middle and early childhood, middle and adult childhood, adolescence, early adulthood, middle adulthood, and late adulthood. And I also suggested to you that in each of these ages, we study how children change cognitively, biologically, and socio-emotionally. So if you look at these 2 arrows I've got here, we're talking about the infancy age for the next 3 weeks. And today we're going over the biological process, and we're talking about physical growth. So if you'll see chapter 4, which is this week, we're going to talk about physical development in infancy. Chapter 5, next week, we're going to talk about cognitive development in infancy. Chapter 6, we're going to start with we're going to talk about socio-emotional development in infancy. And then you know what? We're going to repeat it all over for 7, 8, and 9. Physical development in early childhood, cognitive development in early childhood, socio-emotional development in early childhood. So that's kind of how we're going to do that. I see Eric Fleming, the 13-year-old, is here today. Good to see you too as well, Eric. Man, we have got a full house. The gang is all here. Fantastic. And I want to thank everybody for doing such a great job of coming to class for the live lecture every week. It makes it more interesting for me, and hopefully it makes it more interesting for you when you collaborate with your partners in the chat bar during the lecture. As I think all the other YouTubers say, please subscribe to my channel on the bottom of this video. I'm not sure what actual prize I'm looking to win, but go ahead and subscribe to my channel and you'll get free reminders before every lecture, so you never miss another lecture before. Hey, Lorena's here as well. You know, class just was not complete until Lorena showed up. It's good to see you, Lorena. My goodness, what a big crowd today. All right, let's talk a little bit about physical development in infancy. What you'll see on the left side of your, ooh, look at that. Thank you very much, Ninja Oxendine, for subscribing to my channel. Whoop, look at that. I'm at 153. Oh my goodness, I'm only 90,997 short of making any money off of this channel. Wow. Okay, so back to the lecture. If you will, take a look at this chart over here on the left side of left side of your screen. Have any of you ever seen this chart before? If you have a child and you've been to the pediatrician's office, I guarantee you have seen this. And this is the growth and the height and length expectations for children throughout childhood. And they also have one of these for head circumferences as well. And this allows us to assess the evaluation, the growth of your child to see if they are thriving. Developmental psychologists talk about thriving as being a state beyond mere survival, implying growth and positive gain. Now, a lot of medical doctors are going to talk about this in terms of weight and size gain, thriving as you might think of as a plant growing and getting taller. But you know, I also like to think of thriving as thriving cognitively, thriving emotionally as well. So you can think about doctors as having expectations for all of these aspects of growth. And if you have ever No problem, Lorena, you're the best. And sometimes doctors, when they do evaluations, will even use the term FTT, failure to thrive, to talk about a child who doesn't seem to be growing and developing according to expectations. I saw a developmental evaluation for a girl in fifth grade who was being evaluated for a learning disorder, and one of the things that they listed on her diagnosis chart was failure to thrive, which meant that she had a little bit of trouble growing as a younger child, and that is developmentally important. So one of the things that we're interested in determining whether or not children are healthy and developing in a healthy fashion is by looking at the expectations for physical growth. Okay, so what I'd like for you to know off the top of your head for class, for the exam, is I do want you to know some average growth expectations. So the average American newborn is 20 inches long and weighs around 7.5 pounds, okay? So on the exam, I'm going to ask you what the average American newborn weighs, and I expect you to know these things. Now, of course, newborn size and weight is going to depend on cultural factors, diet, and other kinds of quality of life aspects. So it may differ from country to country depending upon the development of that country. But here in the United States, 20 inches long and 7.6 pounds. Now, most newborns, so that is 90%, from 10 to 90th percentile, are going to be somewhere between 18 and 22 inches and somewhere between 5 and 10 pounds. You know, my biggest hero, my biggest movie star hero is Clint Eastwood. And from what I understand, Clint was a star the day he was born. He was 10.4 pounds, and he made the newspaper because he was such a big baby. Now, babies grow about an inch a month during the first year, and by 2 years of age, infants are going to weigh somewhere between 26 and 32 pounds and average 32 to 35 inches in height. Think about that, growing 50% of their body length in 1 year. I'm 5'6". Could you imagine me growing to 8 foot between now and next year? So you can probably imagine, and if you look at these charts here, you'll see that the growth starts out super duper fast and it kind of trails off a little bit as the child gets older. By 2 years of age, children are going to weigh approximately are going to weigh approximately 26 to 32 pounds and average somewhere between 30 and 35 inches. So within the first 2 years, you're going to triple your weight and grow by 50%. That's an amazing amount of physical growth in the first 2 years. And growth is episodic or sort of goes in jerks and pauses. So I don't know if you had this experience, but for me, it felt like my kid didn't change. And all of a sudden I went in the next day and the little kid just blew up and was a different child within one day. So the growth does sort of occur in this sporadic, episodic fashion. And you can take a look at here. What do you notice about this newborn baby? So we've got the fetal age, and you'll see what the kid looks like in utero. And then look at this newborn. At birth, your head is 1/4 of your body size. That is super duper huge because as a human adult, your head only represents 1/8 of your total height. So infants are born with unusually big heads. And you know what? Your head growth is going to outpace the rest of your growth too. And by the age of 3 years old, your kid's head is going to be adult size. Yeah, it does look like an alien, right? You know, I wonder one day, I don't know if you ever heard the stories, true, not true, I don't know about aliens, but they always have big crazy heads like this. So I'm wondering if this is where we're evolving to. So rapid extensive growth, and you have to be careful. And I'm sure all of you have heard about shaken baby syndrome. These big heads, you can get these heads whipping if you shake your baby. And this is a great way to damage your kid's brain. And so it is very careful how you treat your baby, especially during the first year. Now we're going to talk about it a little bit later on tomorrow, actually Thursday, when we talk about researching perception and sensory perception development in infancy. But there are some non-invasive tools that we can use to measure brain activity. And your book talks about the EEG and functional near-infrared spectroscopy, the FNRIS. And you see a little picture here of the babe with the EEGs all over their head. Or a tiki mask. That's one way to put it. Okay, so check it out. There are two kinds of neurological changes that occur in your brain. Why are babies' heads born so big? Well, that's because your brain has all of the brain circuits that it possibly is ever going to have at birth. And your big competitive advantage in the animal kingdom is your big brain. And so Mother Nature, science, whatever, wants to get it just as big as possible. And if you think about it, that is your competitive advantage. You can't run very fast. You're not very strong. You can't see well at night. You don't fly. Frankly, a nice-sized squirrel could kick your ass, right? You're a very weak specimen in the animal kingdom. So why do we rule? Because we got this right here, this big brain. So from an evolutionary standpoint, we want to have as many things in that brain as possible while still allowing it to pass through the birth canal. So your brain is born with all of its brain structures, but it's missing the fatty tissue in the brain. Erica likes my squirrel joke. It's true, though, man. I faced off with a squirrel as a kid one time, and I didn't want none. That squirrel chased me all the way in my house. So I have a very profound respect bordering on fear for those little rodent suckers. Now, two kinds of changes happen in your brain. The first results from maturation, which is growth after birth that is pre-programmed and doesn't change based upon experience. And the second change that occurs in the human nervous system is dendritic growth, which results from experience, or you might use the easier vernacular, learning. right? And so the changes in your nervous system that occur, especially during the first 2 years, are myelination and dendritic growth. So I'm going to talk briefly about myelination. It's a maturational process that occurs at its own pace. And your brain is not fully myelinated until you are 25 years. The prefrontal cortex of your brain, which controls your future-oriented thinking, your impulse control, and your planning, is not fully done until you're 25. And if any of you have ever run into an 18-year-old, or if any of you turkeys are 18 years old right now, you know you're not thinking about 30 or retirement or stock options. You're thinking about today, tomorrow, and tonight, right? It's only when you get to be my age and old man and your brain's fully myelinated that you begin thinking about the future. So myelination occurs as we get the growth of this fatty tissue around the axons of our larger neurons. Remember from Psych 150, myelin tissue is composed of glial cells, packages of glial cells wrapped around one another, and they insulate the neuron and make the neural impulse move faster. So they actually speed up your neural impulse. Myelination speed and time varies by location. Your occipital lobe that controls your vision is going to myelinate pretty early. Your motor and sensory cortex that controls the feeling and movement of your body is going to myelinate pretty early. But your parietal lobe, which allows you to think abstractly, is going to lag in its myelination. Your prefrontal cortex, which controls your personality and your impulse control, is going to lag behind and myelinate slowly. So your myelination does vary depending upon speed and location. And this is why... That's for the clowns. Thank you very much. Turns out Melanie doesn't like clowns, so she's torturing me with squirrels right now. It's an inside joke. And Melanie, well played, Melanie G. Well played. And so myelination, definitely it occurs most forcefully during the first 2 years of life. And that's why they tell you when you finally do switch your kid off of formula onto milk, you are supposed to give them whole milk, because whole milk has extra fat, which helps develop that brain. I think it's one of the great ironies of life that getting wise means you're developing fat in your head, because I always use fat head as a way of insulting somebody, but it turns out getting fat in your head means you're developing intellectual and physical abilities, right? Now, the second change that occurs in the nervous system is dendritic growth, and this occurs from experience. So if you remember from Psych 150, neurons have terminal buttons and dendrites. Those are the little branch-like structures. At the top are the dendrites on this neuron, and the bottom are the terminal buttons. In your brain, dendrites synapse upon terminals. And when terminal buttons release neurotransmitters, they cause the next neuron to get excited, right? That's what neurotransmitters do. But you know what? The postsynaptic neuron that's getting stimulated, it sort of feeds and nurtures the terminal buttons that are growing that way. And so as one neuron stimulates another neuron, the neuron connections begin to knit together. And you grow these neural connections called synapses. Now, it turns out that you grow twice as many synapses as you are going to need. And what happens is, as that area of your brain matures, the synaptic connections that are not used very often wither and die due to lack of nurturing. So they don't get the food that they need, so those neural connections die. And what happens is your brain kind of sculpts itself into the neural architecture that you need based upon how you use your brain. The peak of synaptic overproduction in the visual cortex occurs around the age of 4 months, caused by a decline around 5 or 6 years of age is when your dendritic pruning finally quits in your visual center. with your prefrontal cortex. The dendritic pruning doesn't reach its apex until after 1 year, and it doesn't finish pruning until your mid-20s. So heredity and environment do shape the timing and course of the blooming and pruning that occurs in your brain. So here's a picture sort of to give you an idea of what synaptic blooming and pruning looks like. You'll see we have the same number of neurons in each of these three panels. These are the neurons at birth. You'll see these are the neurons with all of their connections at 6 years of age, and you'll see these neurons with fewer connections at 14 years of age. So this represents the blooming and pruning of these synaptic connections in your brain. So your brain is changing in two ways during the first 2 years. You're myelinating these neural connections, which are making the different parts of your brain work together. And then also, as you're playing with your baby and stimulating your baby and telling jokes to your baby and tickling your baby and singing songs to your baby, those little dendritic connections are knitting together and wiring your baby's brain so that your baby will be able to function. Okay, now babies do need stimulation. I have a lot of overeducated upper middle class age parent friends who think that you have to give your kid baby Einstein or teach him calculus equations to be any good, or I have to teach him 2 or 3 languages or Greek or Latin. You know what? That's crap. That's crap. That's crap. That's crap. All you really have to do with your babies is play with them. Just have fun. Talk to them, tickle them, show them what you're doing, tell them what you're doing. Really, what you have to do is stimulate your baby's brain. You just have to light that sucker up as much as you possibly can by playing with them. So brains need stimulation for normal development. In fact, we're going to talk about, when we get to language, we're going to talk about critical periods. And critical periods are times in your brain, in your history, when different parts of your brain have to be stimulated in order for normal growth to occur. So there's a critical time for vision in the first couple of months in your life. If your brain isn't stimulated by seeing horizontal and vertical lines, you will actually grow up into a person who is blind to horizontal or vertical lines, because those neurons in your occipital lobe, in V1 of your the V1 cortex of your occipital lobe, will die off if you don't stimulate them. Okay? It turns out that language, we all have this innate ability to learn a language, unless we don't hear a language for the first 3 or 4 years of our life, in which case that brain area gets given to another ability, and we will never learn how to develop the mature language abilities. If you look at the picture that I've got here, it's a PET scan, a positron emission tomography scale that shows the activity of brains. And this is a picture in your book. And what you'll see is we're comparing children from orphanages who were not stimulated on the right with babies who were stimulated on the left, in the left panel. Red and yellow represent higher levels of activity in the brain. Blue and black represent less activities. And you can see that the children who were brought up in a Romanian orphanage and not given lots of stimulation, their brains did not develop as many connections and are not nearly as active as the children who were stimulated. And later on, we're going to be talking about I have a video called The Forgotten Children, which is about children growing up in orphanages. And I think it's a Romanian orphanage. And it shows you what happens when you don't stimulate that baby's brain. Now, I don't know if any of you have ever heard of the Head Start program. Anybody ever heard of the Head Start program? Please type in the chat or send me a text if you have heard of the Head Start program. Been around a long time, since 1965. And it's one of the goals of the Head Start program was to provide stimulating environments for children in at-risk environments. So sometimes you get parents in lower SES categories. Maybe they're dealing with work problems, marital problems, drug problems, reasons that they can't be the kind of parent that they need to be. And it turns out that when their children get to kindergarten and first grade and second grade, they tend to have difficulty and lag behind the other children. So Head Start was originally developed as a way to provide a nurturing environment for these children to make up the loss of stimulation that they weren't getting at home. Now, it turns out that Head Start's kind of a mixed bag. It works well as long as you're doing Head Start, but it turns out that for some of these children, after the Head Start program goes away, they start losing the gains that they made to catch up to their peers who are growing up in better environments. Now, one of the things that your book talks about that I think is super duper important is this idea of the neuroconstructivist view. Is it all environment? Is it all genes? You know what? Brain development is both of those. It's the interaction between experience and gene expression that really causes your brain development. Your brain's going to myelinate genetically. From a maturational standpoint, your brain is going to, if you get enough fat intake to myelinate that brain, but the environment's going to be there. If you have to have enough fat in your body, in your diet to myelinate that brain. Same thing with dendritic spreading. Your dendrites are there and they're ready to interact. You just have to stimulate them. So it's biological forces and environmental conditions that both influence the brain's development. And you know what? The brain has plasticity. I don't know if any of you ever saw the case of Ben Underwood, the young boy who can see with his ears. Young Ben was born, at age 3, he had to have his eyes removed because he had cancer in his optic nerves. And they removed his eyes, and Ben's brain, his visual and auditory centers, reknitted through neuroplasticity, and he now is able to echolocate using clicks, and he can actually see a visual world with his ears. How good is his echolocation? This kid rides a bike, roller skates, plays basketball, and has no trouble whipping his brothers in sports using this echolocation ability. Yeah, Melanie says it's a sad story because eventually the cancer did come back and killed young Ben at the age of 16. But it's an uplifting story if you watch it. Your book talks about Michael Rabin's right hemisphere and other areas of his brain reorganized to take over language functions because his left hemisphere was removed due to uncontrollable seizures. I had a student in my class here at Wake Tech about 10 years ago. I was talking this lecture. She raised a hand and told the whole class that she was missing her left frontal lobe. And you know what? She still looked every bit as normal as the rest of us. That's because our brain has neuroplasticity. It has all these different areas that connect to your body. But if a part of your body is missing, that brain area will find something else to do. On the other hand, if you have a body part that's connected to a part of the brain that's not working, another part of your brain can come in and take over that functioning. So the cool thing about this brain that comes not done, if you will, is that it can shape itself to our environment and also to any biological challenges that we may feel. So I want you to be familiar with this term brain neuroplasticity. And as Melanie suggests, I highly recommend all of you take 45 minutes out of your life to watch the story of Ben Underwood. And if anybody wants me to, I'd be more than happy to send you a link to that video. Okay, now, here's the deal. We are interested in evaluating the infant's development. Now, we know this biological development is occurring, and we know that sometimes for some kids it doesn't occur normally. Now, as a general rule, we cannot get inside your brain and see what's happening. There are neuroimaging methods that allow us to see at least myelination, but this is very expensive and your insurance company is not going to pay for it. So we need another way to assess whether or not your child is developing normally. And so we're going to talk about the concept of milestones. And milestones are nothing but behavioral expectations that we've learned from looking at lots of kids about when specific behaviors are supposed to emerge. And the emergence of these behaviors, abilities, and qualities allow us to guess that your brain is developing normally. Your nervous system is developing normally. If a child is not making milestones, they're not failing to thrive, so to speak, in meeting milestones, that is the first clue to your doctor that there is a neurological problem that needs to be addressed. Now, you'll see up here on this chart, I have reflexes, because the first thing you're going to see in a healthy baby is a set of infant reflexes. They're called primitive reflexes, or your book calls them infant reflexes. Now, all of us have reflexes that stay with us throughout life. In fact, we talk about your spinal column as being a part of your central nervous system because your spinal column controls reflex behaviors. If you've ever been to the doctor and have them bang on your knee with that little hammer and your knee kicks, that's a reflex, a patellar reflex that is probably involved in helping you stand. Infants are born with a set of reflexes that die off halfway through the first year. These reflexes are there to provide adaptive behaviors until myelination allows the brain to take over voluntary control. Some example of infant reflexes that will go away: the sucking reflex. You put anything in a baby's mouth, it will immediately start sucking it. Any of you have an infant, stick your finger in there and see what happens. It's like this huge suction that this kid will automatically engage in. That's a feeding reflex. They have another feeding reflex called the rooting reflex. You take a little baby and tickle their cheek, and they'll turn their mouth and start looking for a breast to suckle on. And this allows them to find food before their visual centers are developed enough to let them see food. It's sort of a touch reflex, if you will, that helps them feed. There's also a Moro reflex. Take your little baby and just drop them a little bit. Don't drop them, but just let them change height in a quick second. And what you're going to see is the baby's arms will splay out to the right and the left. And this is sort of a safety. If the mom was scared and took off, the baby clings to the mom. So the Moro reflex is kind of like a gripping reflex. And then if you've ever put your hand in a finger in a baby's hand, you'll notice that the baby wraps around it super duper tight. And in fact, this is where we first start our gender stereotypes, because if your little boy does it, we all say, "Ooh, look at that strong little grasp. What a little man." We actually start gender typing even at that age. Your girls are going to do it too, but we seem to make that some sort of thing about strength when little boys do it. But these reflexes will die somewhere between 3 and 6 months as the baby's myelination begins to take over. So, what should we see? If you remember last week, we were talking about those neonatal evaluations of babies within the first couple of weeks to see if their nervous system is organized. You can think of milestones as expectations and organizations of the nervous system that we expect to see later in life. So, how's this development going to occur? There are two terms that can be used to describe the pattern of development that you're going to see in young children: cephalocaudal and proximodistal. What you're going to see is that the baby is going to start to take control of things near the head before it starts to take control of things near the feet. So the first thing your baby's going to do is move that head and open that mouth and turn and move that neck all around. Then your baby's going to start using their arms. Then your baby's going to develop enough trunk control to sit up. And then maybe your baby might develop enough leg control to stand up. So you'll notice that the development goes from the head to the tail. We call that the cephalocaudal principle. And also you're going to see that children are going to start using the body parts near the midline of the body long before they can use these little finger things very well. And we'll call that the proximo-distal principle, and with gross motor abilities developing before fine motor abilities. What's a gross motor ability? It is any ability that involves large muscles. Your spine, your legs, lifting your arms. Those are all what we call gross motor movements, gross motor behaviors. On the other hand, fine motor behaviors are those that require teeny tiny small muscles, like I'm speaking right now, and my teeny tiny lip muscles are allowing me to create all these amazing words in this amazing lecture. Or, more simplistically, we might talk about the old pincher grasp. And if you've ever watched children, they develop the palmar grasp first, which is this horrible sort of, you put something in a kid's hand and they can't kind of grab it like this because they don't have what we call the pincer grasp. Palmar grasp, pincer grasp. And if you folks have ever been to kindergarten, do you remember kindergarten when we used those super duper fat pencils and we used that lined paper with the lines that were like an inch wide? And we did that because our fine motor abilities hadn't developed yet. We're learning how to write, but we're not so good with our C's and H's. Somebody's had multiple cups of coffee. Yes, Melanie, I am as high as I could possibly get on caffeine right now. Okay, now, one of the things that happens with children is they have to learn how to hook up their eyes and their ears and their other senses with their motor movements. We call this perceptual motor coupling. All right, and this is controlled by a connection deep in your brain called the superior colliculus, which is down at the bottom of your thalamus. And this allows us to coordinate our sensory experiences to our motor movements. So how many of you can easily pick up a pen that is laying on the table? You know what? That actually requires you to see the pencil, know where it is in space, and direct your hand to the appropriate place to pick it up. I have just demonstrated good perceptual motor coupling. You know what? That's what kids got to do during the first year. They learn how to put motor behaviors together and use sensory information to guide those motor behaviors. Now, this is incredibly important before your kid can do anything like hold something or look at something. So, children perceive in order to move their body, and by moving their body, they change their perception. So if you've ever been down to Walmart for a birthday gift and gone through aisle 1 of the children's toy aisle, what you're going to see are all kinds of educational toys. And I remember before I was a developmental psychologist, I used to ask myself, what does a rattle or a little triangle, those little circle donut thingies that you're looking at below me, see below me, why are those? They called those educational toys. And I never knew why that was educational. But it turns out that what these toys do during your first year is teach your kid how to coordinate their senses with their motor behaviors. So you'll notice the kid pushes a button and a light lights up and a song plays. So your kid's learning that their body causes sensations to occur in the environment, and that these sensations are then related to their behavior. So your kid learns to shake a rattle and make noise. Your kid learns that some donuts are bigger than other donuts. And so these toys that we give our kids during the first year allow them to couple their perception with their motor abilities. Okay, now there are all kinds of motor stones of milestones. There are actually milestones for every developmental category. So there are physiological gross motor milestones. There are fine motor milestones. There are cognitive milestones. There are social milestones. There are language milestones. And each of these categories has an expectation for when we expect these behaviors will emerge in children. A fellow named Arnold Giselle, way back in the 1930s, was the first person to come on this insight. And he realized that most children develop the behavioral abilities in about the same order and about the same time. So if we know that, we can then evaluate children to see if they are keeping up with the Joneses, as it were, or developing along with the other children. Right? And there are lots of different kinds of questionnaires that you can use. The ones that my doctors used at Fuquay Pediatrics, where we took our boys, they used the Ages and Stages questionnaire. But there's also the Giselle Developmental Observation, which is for a little bit older kids. You know what? Melanie wants to know, are we going to have to know what happens at what milestone for the exam? That is a fabulous question. And you know what? That's a little too petty for me. How about that? But I do want you to know that these red bars signify the 10th and 90th percentiles of when this behavior is observed. So 10% of all children are going to be able to lift their head at birth. All but the last 90% of children, only 10% of children are going to be able to lift their head at birth. But by 3 weeks or a month of age, 90% of children are going to be able to lift their heads, okay? Let's see, by 6 months, only 10% of your children are going to be able to pull themselves to a standing position. But by about 10 months, 90% of the children should be able to pull themselves to a standing position. I don't really want you to know all of these, but I do want you to know that they represent a range of when we expect these behaviors to occur, and that most children can stand and walk probably sometime around 12 months of age. I might ask you that general question. You should expect your kid to be walking 10 to 12 months. If they're a bigger, heavier kid, maybe not, because it's harder to move that big body around. If your kid's got a big Roddenberry noggin, they may not be able to walk as early because of the difficulty with that head. But as a general rule, these are good expectations. Now, there are lots of milestone evaluation categories. Like I said, there's the growth milestones that I showed you in the first chart with the length and width of the length and weight of children. But then there are physical milestones, cognitive milestones, socio-emotional milestones, and language milestones. The chart that you're looking at right here is the gross motor behavior expectation milestones within the first year. Okay, and part of learning how to walk is learning how to balance on one leg. Right? You have to develop this posture, a gross motor ability. You have to be able to balance on one leg so that you can move the other leg out in front of it and get them going, right? You have to learn which surfaces are good to walk on and which surfaces are not good to walk on. That's some of that perceptual motor coupling again. And then, of course, you have to practice that skill. And when we talk about sleeping and REM sleep next week, I'm going to suggest to you that some of that practicing or brain stimulation actually occurs while we dream. Imagine practicing walking while you dream. Okay? So let's say, now one last point that I did want to make on these milestones. Just like some of you are always late to class, some of you are going to be late on your milestones. It just happens. And so really, when you want to evaluate a child, you have to take into account two factors. Is that child hitting all of their milestones late? Some children are just late, but as long as the child is making smooth progression through the milestones, your pediatrician is not going to be worried. Most kids are supposed to walk by 10 months. Your kid walks at 14. Most kids say the first word around 12. Your kid waits till 15 months. But as long as your kid is making that progression, the doctor usually isn't going to be worried. What worries a doctor is when you stop making milestones. So let's say you hit your 6-month milestone and then you don't get any better after that. That is supremely worrying to a doctor. Most children engage in their social smile around 3 months of age, and that's a social milestone that allows us to see that your personality is developing. What you're going to see is that some children who are on the spectrum may lose that social smile. So sometimes they'll even begin losing milestone behaviors. So your kid might progress all the way up through the 9-month social milestones, and then in 10 months, they're acting like an 8-month-old. And then in 11 months, they're acting like a 7-month-old. So some children actually will regress on these milestones. And these milestones provide an early clue that your child has some sort of neurological problem that needs to be attended to. Now, as I mentioned from the neuroplasticity slide, three slides earlier, the earlier we know about these problems and the earlier we engage in interventions, the better the outcomes are for these children. Now, can you save a kid who has a severe developmental disability? No. But what we can do is we can improve the outcomes for these children by early intervention. Do I have any questions so far? You know what? We're at 1:43. I'm 2 minutes earlier. Yay. I was 10 minutes late in my intro psych class today, so I feel like I've picked up a couple of minutes in my life. That's all I really had to talk about today. On Thursday, we are going to talk about sleeping and dreaming, and sleeping in infancy, sleep patterns in infancy, and we're going to talk about infant cognitive research. I'm going to send you an amazing video called The Baby Human, which demonstrates some of the research methods and research findings that have been discovered with infant children. I'm going to send that to you before your Thursday lecture, and hopefully you can watch a few minutes of it and get a feel for how we do research with people who can't talk and tell us anything. It's tricky, but you can do research to find out what's going on in a baby's mind. And we're going to talk about that on Thursday. Is there anything we need to watch for tomorrow? Yes, Melanie, I forgot to put it in the folder for tomorrow. I will have that video and instructions for you later today. And when I have it done, I'll send a text out to everybody letting you know. Okay, I'm still deciding on one of 2 films, so I'm not sure where I'm going to go just yet, so I don't want to spill the beans. Does anybody have any questions? If you don't have any questions for me, I'm going to go ahead and end this class. As Mel G mentioned, we are having the webinar tomorrow at 1 o'clock, and I hope we have the amazing attendance that we've had so far for the first 3 weeks, with over 67% of you attending every webinar. I'm really excited about that. If you don't have any questions, I'm going to go ahead and say goodbye. I will see you tomorrow in webinar. Take care.